about assembler.
Yeah, I cannot even start with this last problem.
But not for this course?
No,
No, a different course.
and
You're doing assembly. You're doing a course on assembly.
yeah,
Well, that's cool. You have to do a stack.
yeah, I've done the last of that.
Oh, cool. Cool. I had a co-op term in which I wrote in assembly a program to condense an image. It took me the whole work term. Is it a required course? I didn't know. Are you an engineer? Software engineer? And you have to do assembler.
Assembly, yeah.
That's painful.
Yeah, it's horrible. Don't be
I thought we were past that.
Apparently, we have to know how to transform from integers to binary because like a computer doing it's not enough.
So you have to write code in assembler.
And then we're going to learn about compile.
Fair enough. I have some slides on a compiling algorithm. And when I never took a course on compilers because I don't want to actually code. But when my son was 10, not 10, he was in grade 10. He had to do a computer science project, and we wrote a pretty good compiler.
I was like 15.
No, let's be honest here. He was helping me with the coding, and I was telling him how to do it.
That was like the first out of my ego because I can barely write hello world.
Yeah, yeah. Yeah, well, my compiler is online if it's helpful to anybody. And if people...
Have you thought 2021 or
2021? No. No, I didn't even take it as an undergrad. I did it as a co-op term, but I don't think I ever have done a course in assembly.
Lucky right now is like I barely understand the teacher what she's saying.
Wow. I don't know if you heard, as a co-op student, I wrote a program to compress images in assembler. So I was just looking at zeros and ones, crazy pants.
No, but he's amazing.
Is he? Hey, you're amazing.
No, like he always like responds to the teacher.
Right.
Like Brian barely understand. I'm in the same boat here. Like he's always like responding to everything. He gets like A, straight A. Like he's fucking academic level.
You should teach them all.
Like you should.
All right. So when I teach 2101, it's writing Turing. You're looking at Turing programs, and it's more or less like assembler. I would really recommend that you focus on loop invariants, right? And you say, what do I want to be true here? What do I want to be true here? And so you're just writing assembler to go from one to the other, you know? The state, I'm in this state which says I have, what line of code am I on? In fact, if I had to do assembler, I would write pseudocode of how, at a more Java level, right? And then I would say, I'm at this line of code, what state I'm in, what's the nature of all my variables, and then how does that picture change when I get to the next line of code? You know what I mean? For every line of code in your pseudocode, say, where am I and where do I need to be at the next line? And then you only have to write enough assembly code to execute one line of your pseudocode. You know what I mean? And once you got a good of how to writing one line of your pseudocode in assembler, then you just have to do it for every line of your pseudocode. You know what I'm saying? Anyway, that's my recommendation. I keep meaning to go get more markers, and I haven't. So, it's funny how many people are in here, because my morning class, about this many people show up. and we had a test this morning. Holy cow, where did all these people come from? I have never seen so many people in that class. So I assume they're somewhere in the world. So I appreciate you guys coming. And I particularly appreciate those who talk to me. All right, so I don't know if you've heard, assignment 2 has been posted. And is there a little program I can scribble on? Here, let's. All right, so I looked over the assignment. And again, you know, I believe in loop invariants. And my attitude was you could do it all. All right. The one question I got a little stuck on is I have a hard time when it said the last one is shift right versus left. And do I remember which is my right and which is my left? And am I moving right? It says shift right. Am I moving right, or is the string moving right? You know, in his example, if you watch this little example, it's only of length 4 and he shifts it 2. So you don't even know whether you're going right or left. So I sort of thought about it and said, well, if this is, right, this is a linked list, right? I'm pointing at 0, 0 is pointing at 1. And if I shift it to the right, then this 6 comes over here, right? And then I shift it one more time to the right. And it comes over there, right? So that's shifting twice to the right. And he kind of came up with, in his video, he came up with an equation, which is size minus n minus 1, right? And you have to know what that is. Well, the size here, I guess, is 7, right? Because let's go back to what we were starting with. We have 0, 1, 2, 3, 4, 5, 6, right? So the size is 7, right? And so 7 and n, we shifted twice. So n is 2, and he had an extra minus 1 in there for good luck, which gives you 4, right? And what is 4? 4 is going to be on the end of your new list, right? It's kind of like we cut it between 4 and 5, right? So I don't know whether when you arrive with this problem, you know how big your array is. I assume that it's your linked list. This is a linked list, right? I assume your linked list knows how big it is. It knows the size. If not, you're going to have to count them. And I assume it knows n, that's the input. So it can calculate this number 4, right? And so you gotta, how are we going to get to 4? Remember the linked list? You got to walk there. Remember, if you look on my page, we wrote code for walking, right? So what do we got? We start off with a pointer to 0. That's the beginning of the list, right? And then you walk. You know, I like to have a I like to have a, no, don't do that, guys. I like to have a pre and an after, you know, a current to next. Remember, we walked with 2. Advantage of walking with 2 is, well, you know when you've passed it and you know, right? Anyway, if you have 2, then you have a pointer here and a pointer here. Do you need 2? I don't know. You have to see whether you need 2, right? And so then what we have to do is we have that picture, and you have to rearrange it, right, into this picture. And it's just a matter of shifting the pointers around. Everybody see? Any questions about this? Does that mean everybody understands it or everybody's lost? which, good. People good here? So I think that's the level of questions you're going to have on this test, on this, you know. And so it's a matter of coding it up. And then the test that we're going to have, right, in the lab, you're going to have to do, I think he told me 3 or 4 of these questions in an hour in real time, right? So I would hate to be doing that, right? So you have to really get both the types of algorithms that we've done so far, and you have to really get the Java code, right? So I apologize because I wouldn't want to be doing this. Any thoughts on it?